Is this the best type of roller for this work? Is the soil in the correct moisture condition for compaction? Is the plant being operated in the most efficient way using the right number of passes? Is the right thickness of soil layer being employed? The answer to these questions is very important to the engineer because road construction usually involves a considerable volume of earthworks, the cost of which, in the case of the modern motorway, may amount to as much as 40% of the total expenditure. Since 1945, with these points in mind, the Road Research Laboratory has been carrying out a program of research in which studies have been made under controlled conditions of the performance of most types of compaction plant available to the engineer in the British Isles. Increasing the state of compaction of soil increases its strength and reduces the possibilities of settlement. If, therefore, economical designs of road embankments and pavements are to be obtained and subsequent maintenance reduced to a minimum, the soil in the embankments and subgrades must be brought to a satisfactory state of compaction during the construction work. In order to carry out the full-scale compaction tests under controlled conditions, a special building has been constructed at the laboratory. This building is 100 feet long, 90 feet wide, and contains 5 soil bays. Each bay is 35 feet long, 15 feet wide, and contains a 3-foot depth of test soil. The soils used are a heavy clay, sandy clay, gravel sand clay, and 2 types of sand. These are chosen as being representative of a wide range of British soils. To prepare the soils for the tests, special mixing machines have to be employed. The largest of these machines used at the laboratory is the 80 horsepower tractor with an agricultural type of rotavator mounted at the rear. The rotavator has a series of digging blades which are driven at a speed of about 120 revolutions per minute. With this machine, it is possible to break up and mix a depth of 12 inches of compacted soil. Besides having the normal range of speeds, this machine, with the special gearbox fitted, can travel at low forward speeds of a few feet a minute. This enables a very high degree of efficiency to be obtained in the pulverization and mixing of the soils. To start a full-scale compaction study, the layer of soil under test has to be broken up to form a loose tilth representing a completely uncompacted state. Any adjustment of moisture content that is required is effected by spraying water onto it, followed by further mixing. If a reduction in the moisture content is required, this is obtained by aerating with the rotavator. Samples are taken to determine that the soil is the correct moisture content for the test. The mixed soil of correct depth and moisture content is finally raked level. To illustrate the procedure used, let us look at the test work with a heavy pneumatic tired roller. This type of roller is widely used throughout the world for the compaction of large embankments. It can be ballasted to a total of 45 tons, which is carried on 4 heavy pneumatic tires. Inflation pressures of up to 150 pounds per square inch can be employed. The wheels are arranged in pairs on pivoted axles and are fitted with heavy-duty earth mover tires. The roller is being towed by an 80 horsepower track-laying tractor at a speed of 1.5 miles an hour. In determining the relationship between the state of compaction of the soil and the moisture content for the machine under test, the soil is compacted by a sufficient number of passes of the machine to ensure that little further compaction could be achieved. That is, the soil is compacted to refusal. With rollers, this is usually achieved after about 16 passes, but in order to be quite sure, 32 passes were given in these tests. The state of compaction of the soil is measured in terms of the dry density. That is, the weight of the dry material per unit volume of compacted soil. In order to ensure that an accurate and representative result is obtained, 10 determinations of dry density are made over the compacted area. Personal bias in selecting the points where these measurements are to be made is eliminated by employing a standard pattern. The method used for determining the dry density of the soil is the British Standard Sand Replacement Method, which is suitable for all types of soil. After trimming level the surface of the compacted soil, a hole about 4 inches in diameter and 6 inches deep is carefully excavated, all the soil from the hole being collected in a tray. The volume of the hole is found from the weight of closely graded dry sand required to fill the hole. A standard pouring cylinder is used to provide a controlled rate of filling, allowance being made for the weight of the sand trapped in the cone. The dry density of the compacted layer is taken as an average of 10 determinations, giving an accuracy of about plus or minus 1.5 pounds per cubic foot. In order to calculate the dry density, it is necessary to determine the moisture content of the soil. A small sample of the soil from the hole is taken and weighed. The sample is then dried in an oven controlled at a temperature of 110 degrees centigrade for 24 hours, after which it is re-weighed. The loss in weight of the sample, expressed as a percentage of the dry weight, gives the moisture content. After the measurements of the state of compaction have been completed, the soil is again broken up and prepared for the next tests. The compaction procedure and the density measurements are repeated with the soil at a different moisture content or with different numbers of passes of the machine. 3 main factors are studied in the tests. Firstly, the effect of the moisture content of the soil on the state of compaction obtained. This relationship shows the range of moisture content over which the machine can be usefully employed and the state of compaction which can be achieved. Secondly, the effect of the number of passes of the compaction plant on the state of compaction. This relationship shows the limited number of passes of the machine, after which little further compaction was obtained. A knowledge of this is essential for the efficient and economical operation of the machine. The third factor studied is the change in the state of compaction of the soil with depth. This is found by making dry density measurements on successive 3 to 4 inch layers throughout the full depth of the compacted soil. The maximum thickness of the layer, which can be compacted satisfactorily by the machine, can be arrived at by these measurements. A knowledge of the 3 curves obtained on the test soils for various types of compaction plant enables the engineer to select the most suitable machine to be employed for any particular work. He can also specify the most satisfactory and economical method of operating the machine. Only in this way can the necessary standard of earthwork construction be achieved at the minimum cost.